practice test for chapters 1, 2, and 3. Let's move through these questions. You do have the answer key for them, but I'd like to call out why each answer is correct. So the first question, we're asked to identify the population and the sample. A survey of 1,947 American households. So we'll stop right there. When you are taking a survey, you are asking some of the people in a population. How many? In this case, 1,947 American households. This is a sample. So I'm just going to label it this way. Once you've identified the sample, because it was a survey, it would only have been a population if they called it a census, that they asked everyone. But there's certainly more than 1,947 American households. But it does identify what the population would be. The population is going to be equal to all American households, or whatever numbers, whatever names here, right? So it's oftentimes easiest to identify the sample, and then from that we can say that the population is going to be all of whatever they're talking about. Now some people get thrown off because there's another number here, but this number, 53% of the households, that's not a sample. It's not what it's referring to. This was taken from the survey. This is going to be a statistic. Okay. Because whenever you do a calculation of a value based on a sample, you have a statistic. That leads us directly into question 2. The difference between a parameter and a statistic is where the value comes from. Parameter comes from a population. Statistic comes from a sample. So as we asked here, a recent survey, and we want to stop on that important word. Since we're taking a survey, I'm going to guarantee you we got to have a sample here, as long as they're talking about that. A recent survey by the alumni of major university indicated that the average salary of 12,000, that's their sample size, they went and asked 12,000 of its populations here. So they're working with a sample. This is a value applying to the sample, not to the population. This number is a statistic. Now, if they asked all 175,000, or if this number somehow was being inferred that it applied to the 175, then it would be a parameter. Right? So it's got to be parameters only apply to the population. Identify whether the statement describes inferential statistics or descriptive statistics. Inferential, go from a sample to a population. And descriptive statistics are dealing strictly with numbers within a sample. There's a relationship between smoking cigarettes and getting emphysema. Smoking cigarettes and getting emphysema. That's kind of a global statement about a population, not just saying that it's related to some small sample of people, that in certain people this happens, but this is a generalized relationship within a population. This is inferential statistics. So know the difference between that. Identify the dataset's level of measurement. Temperatures of 20 selected refrigerators. So first of all, since temperature is a numerical value, it's going to be either ratio level or interval level. Ordinal and nominal deal with names. Nominal is name. That's Latin for name, basically. Ordinal means names that can be put in order. That's the Latin ordinal for order. So it's interval or ratio. One way we can tell is temperatures is how does 0 behave here. So temperature of 0 degrees, does that mean none? No temperature if we're at 20? No, it just means it's part of a scale. We could go -1 degree, we go +1 degree, so going up on a thermometer. So 0 is not none, it's just part of a scale. That is what makes it interval. And in fact, if we did, if you try to make a ratio, is 20 degrees twice as hot as 10 degrees? We do this. But yeah, you get a 2, but how about 9 degrees compared to 20 degrees? There's a difference. We could subtract them, but taking dividing the units really doesn't give us anything of value. So we're going to go with interval. Annual salaries for all teachers in California. Again, we look at how is 0 represented? What does 0 mean here? So if you're making $0, does that mean you have no salary? That's exactly what it means. So here 0 is not just part of a scale, it means the end of the line. And additionally, so since 0 is the end of the line, it means nothing if you were to take 20,000 salary divided by 10,000. This does have meaning. The one who's making 20,000 is making twice as much as the one that's making 10,000, because you've got this starting place of 0. So in that case, again, the two choices would have been ratio or interval. These two, ordinal and nominal, not being considered because it's not qualitative data, it's not names or ordered names, it is numerical value. But since 0 means none, that's when we go to ratio. Okay. Determine whether the study is an observational study or an experimental. For experiments, you need a treatment. So as we read through, we'll see, is there a treatment? Observational, you don't make any actions, you don't treat, you just collect data. A researcher obtained a random sample of 100 smokers and a random sample of 100 non-smokers. After interviewing all 200 participants in the study, the researcher compared the rate of depression among the smokers with the rate of depression among non-smokers. Okay. Was there any treatment? Did he force these 100 here to smoke and then force these 100 here to non-smoke? No, they were chosen because they self-identified as either smokers or non-smokers. This is not an experiment. There is no treatment. It is an observational study. Identify the sampling technique. So we've got to know all these different sampling techniques, and on the exam you may get ones that are similar or are asking for different. So at a local community college, 5 statistics classes are randomly selected out of 20, and all of the students from each class are interviewed. This has the markings of cluster sampling. In cluster sampling, things are divided into groups, in this case classes, and then you randomly select some of those classes, and then you sample. Well, that's your sample, the whole class. So in this case, yes, everybody in that statistics in the 5 that were chosen are sampled. So that's a cluster. So it's the ones that get confused. Cluster and stratified are similar. Stratified, though, is you break them into group, but that's more like going with by category, and then you don't sample everybody in them. You just take some of the stratus. So maybe by age, and then you take 20 of each age group, something like that. That would be stratified. Cluster is they're broken into groups. Think about it kind of like by location, because each class would be in a different location. They're grouped physically, and then you interview everybody in there, but you randomly choose which clusters are going to get asked. So these B and E are very similar, but this would be E, and this would be B. Community college student interviews everyone in a particular statistics class to determine the percentage of students that own a car. That sounds like something you'd want to know about a whole population, not just necessarily statistics students. And everyone in that statistics class sounds like he just had to get some homework done and was taking a convenience sample because that was the easy thing to do. Just ask everybody in that class. Making sense so far? So let's keep moving forward. I'll have a few more questions on the next page. Use the given frequency distribution to find the class width, class midpoints of the first class, and class boundaries of the first class. So we can see here the width, if you count, you've got 50, 51, 52. It's got a width of 3, right? 3. Now, if you just subtract them, you might, 50 minus 2, you get 2. But there are 3 numbers here, and the boundaries are included, right? So it's got 3. So we've answered that. Class midpoints of the first class. So here in the first class, what's the midpoint? Well, halfway between these two is going to be 51. And you could get that by 50 plus 52 divided by 2, and you're going to see you'll get 51. And then finally, class boundaries of the first class. So the class boundaries, since 50 is included and 52 is included, we need to get a half on either side, right? So we subtract a half from 50. So 50 minus 0.5, and then 52 we're going to add 0.5, and so we get 49.5 and 52.5 for the boundaries. So that's why we're going to go with D.